Hello YouTube, in this video we're going to continue our practice with hyperbole, but in this video we're going to focus on doing two things, going from an equation in general form to an equation in standard form and then sketching it, and then also going from maybe a rough sketch back to an equation in standard form. So either way we want to deal with equations in standard form. Let's start with this here. It says sketch the hyperbole given by this equation right here. Now one thing I do want to kind of point out here is this, but between your x squared and your y squared term, notice that you have a difference. So this is going to be one real good indicator that you're dealing with something that's a hyperbola in the first place and not maybe a circle or an ellipse. Okay, so when we look at this here, what we want to do is put this in a standard form first, and remember that standard form takes on a form that looks like this, where we have two perfectly squared binomials, everything's equal to 1, and then we have some different values downstairs being squared. In this case there's a difference, and of course we could say we'll switch around your x squared and your y squared terms here, and you would have a hyperbola oriented vertically instead of horizontally, since x came first here. But essentially in this case what we want to do is we want to put this from general form into standard form, which means we're going to need to complete the squares. So here's what I'm going to do. I'm going to group up my x squared terms here, my x terms. We say 4x squared plus 8x, it seems, plus 8x, and then we would say now minus 3y squared minus 3y squared. We have no other y term here. That's okay. And then we'll go ahead and toss this constant on the other side. So we get a negative 16. So when we deal with this here, first thing we want to do is we want to make sure that we have a leading coefficient that is a 1 here before we complete the squares. So we're going to factor out this form. We get x squared plus 2x plus blank. And in this case right here, this is pretty cool actually. We get 3, and we could say that this is y minus 0 squared. Okay, and this is equal to negative 16. And the reason why we get away with that is because really, I mean, that's the same thing. Okay, you could add plus 0y here and go through the completion of the square, but you're going to get the same things. Okay, so now I'd say, well, what do I really desire to have in this spot right here? I really want to have half of 2 squared, which is 1 squared, which is 1. So now if I took 4 times 1 here, I really added 4 to the left side, so I'm going to add 4 to the right side. I'll try not to draw on my grid too much here. But basically it boils down to this. We say 4, and this would be x plus 1 squared minus 3, and then I'm going to say just y squared. It's really, you can write it as 3y minus 0 squared, but I'm going to write 3y squared, and this is all equal to, it seems in this case, 12, and we're going to divide everything by 12 now, since we need the right side to equal 1. And essentially now we've gone from general form, which equals 0, into standard form. So I'm going to simplify a few things here. First thing is this. We say 4 and the 12, that would make this a 3, and then my 3 and my 12, that would make this a 4, and then the right side becomes 1. So here's our standard form equation. We have x plus 1 squared all over 3, and I'm going to write it, I'll write a 3 for now, minus, now we have, okay, well, this would be y squared, or y minus 0 squared, all over 4 is equal to 1, and I'm also going to rewrite this again. I'm going to call this x plus 1 squared over the square root of 3 squared, minus now y squared over 2 squared. So a few things that I want to say here. I want to say that a is root 3, first of all, and b, 2. And we say that, in terms of h and k, we could say, well, h and k, h is always paired with our x term here, so we say it's negative 1, and our k value must be 0. So now we know a few things about this, starting with the center must be at negative 1, 0. So I'm going to go ahead and start by putting that on there. I'm also going to comment that because of our x term coming first here, we have a horizontal axis. Okay, transverse axis. So I'm going to go left and right from this, the square root of 3 in distance. And what I know about the square root of 3 is a little bit bigger than 2, a little bit smaller, a little bit smaller than 2, a little bit bigger than 1. So I'm going to go almost 2 to the left and right here. And that's going to get us to a couple of vertices here. And then we also say up and down. I'm going to go 2 up and 2 down. So I went 2 up and 2 down, and these points don't actually exist, but remember, what this is allowing us to do is draw this little imaginary box that runs right here, because what we want to do is we want to just go ahead and draw on the diagonals of this box and say, well, look, now the rest of this is just, we have a hyperbola that is approaching the asymptotes. So the very, very last thing that I want to do here, that wasn't really a requirement for this, but I want to do it, is I want to find the equations of these asymptotes. And recall that asymptotes are given by the equation y equals k plus or minus, and there was either b over a or a minus b times x minus h, where h and k are our center, and we say that we know the center here is a negative 1, 0. This is our h and our k, and we know b and a down here. We say a is root 3 and b is 2. So since this was a horizontally oriented transverse axis, we say it's b over a. Had this been a vertically oriented transverse axis, you're going to have to remember that it's a over b, but in this case we say the asymptotes are just simply given by this. We say k plus or minus, we say b over a. Our b value here is 2. Our a value is root 3, and we say x minus h. So x minus, I'm going all sorts of different colors here, and our h value is negative 1. So we get this really, we get, 2 root 3 thirds plus or minus, and that's times x plus 1. And that would be the equation of the line right there, those two lines. So the last thing I'm going to do here is find the standard form of an equation given these, initial properties here. Vertices at 3, negative 5, 3, 1, and then asymptotes thusly. So the thing I kind of want to point out here is this. You always want to start with a sketch of what it is that you're dealing with, okay? So let's see here. We say 3 comma negative 5. We would go 3 to the right, down 1, 2, 3, 4, 5. I'll try to leave some room here. So 3, negative 5, and we say 3 comma 1. So the first thing that I'm tipped off to is the fact that these are the vertices, and so the midpoint of this has to be our center. And so we would say that this is 3, negative 2. So already we know, that the centers here we have h and k. The only thing I want to find now is I want to find a and b. So we say a, b, and c are these three values we usually know. What I do know is that a is the distance from here to a vertex. Okay, so we would say that a is the distance from here to a vertex. In this case, I've gone, let's see, 1, 2, 3 up and 1, 2, 3 down. So we say that that's going to be thus. And we don't know what b is, and I certainly don't know what c is. But what we were told here was that the two asymptotes actually run y equals 2x minus 8 and y equals negative 2x plus 4. So if we were to sketch these in, we say, okay, well, 2, 3, 4. And we go down 2 over 1, down, another 2 over 1, down another 2 over 1, and just keep doing this here. We would say that we've got a asymptote here, and we also know that, let's see, negative 8. 1, 2, 3, down 8, and then we go up 2 over 1, up 2 over 1, up 2 over 1, and we're getting this graph that runs here. Okay. So in terms of a and b, one thing is for sure here. We say in either case we're getting plus or minus 2 as a slope, and I just wanted to draw in the picture so that we could see this a little bit better here. But one thing I will point out here is this: in either case we'd say plus or minus. Since our horizontal axis runs vertically here, remember we said that it would be a over b as our slope. So we could say that a over b in this case is actually equal to 2, or negative 2. So knowing that a is 3 here, we could say, well, a is 3. Then if I know that a over b is equal to 2, then I could also say it follows that a is 3, and this is b, and is equal to 2. And so if I were to now run some magic here, we say we could do a proportion. We say 2b equals 3 times 1, and b equals 3 halves. That's going to allow us to get our b value here. So we say b is essentially 3 halves. So, not very pretty, but basically if we wanted to write the equation of this now, we certainly could do it. And we could say that since the vertical axis runs north-south, since it runs up and down, we'd say that our y term here would come first, and then our x term would come second. And then we would say furthermore, we would say that in terms of what we have here, we say this would be x is 3, so we say 3. And we say k is negative 2, so we say there. Okay, so that'd become a positive. And then in terms of a and b, we would say that it went 3 up and down from the center, and it's going to go left and right here, and I better put squared around those. Left and right, and that would just be 3 halves, which is not very fun, but I would say leave it like this for now. Cheers.